Hello students, in this video we are going to discuss 1.13, 1.14 and 1.15 as per new textbook. Figure shows tracks of three charged particles in uniform electric field. Give the signs of the three charges. Which particle has the highest charge to mass ratio? Here there are two sub-questions. One, we need to identify the nature of the charges on the charged particles. One more thing, we have to find out highest charge to mass ratio. If we observe this diagram clearly, initially the particles are entering into the uniform electric field horizontally. So each and every one has the horizontal velocity, there is no vertical velocity, there is no vertical component. Once if they are entering into this region has the electric field like this. Y means above positively charged plate is present, below negatively charged plate is present. Because of this electric field, few charged particles, they are deflected. They are deflected. If you observe, particle 1 and particle 2 are deflected upwards, that means in the opposite direction of electric field or towards positive plate. So then definitely 1 and 2 will have the negative charges. While coming to the particle 3, it is deflected in the same direction of electric field or towards negatively charged plate. This one will have positive charge. We will write the same. For the first subpart, we will write the particles 1 and 2 have negative charges because they are being deflected towards the positive plate. And particle 3 has positive charge because it is being deflected towards the negative plate. This is the answer for the first subpart. And next subpart, we need to find out the highest charge to mass ratio. Here if you observe, particle 1 and 3 are deflected along positive y-axis, particle 3 is along negative y-axis. Now what is the acceleration of the particles? Acceleration is equal to force per mass. Here we are using electrostatic force, that is QE by M. And the deflection along y-axis, S suffix y is equal to uyt plus half ayt square I am using. Initially, the particles are moving horizontally. There is no vertical component. So, uy is 0 plus half ay is nothing but qe by m into t square. That is equal to half qe by m into t square. It is nothing but sy, otherwise we can take y. So from this, half m, e, t are constants. We can write y is proportional to q by m. That means as the particle 3 suffers maximum deflection, that is y, in y direction. So, particle 3 has the highest charge to mass ratio. This is the answer for the second part of the question. Coming to 1.14. Consider a uniform electric field E bar is equal to 3 into 10 power 3 I cap Newton per Coulomb. Here electric field is along x direction but uniform. What is the flux of this field through the square of 10 cm on side whose plane is parallel to yz plane? The plane of the square is parallel to yz plane. So normal vector will be along x axis. Okay, we will find out the area. We need to find out here flux for this part A. The area A of the plane can be written as 10 centimeter into 10 centimeter, that is 100 centimeter square. We can write this is 100 into 10 power minus 4 meter square, that is 10 power minus 2 meter square. If you are writing vector form of this, A bar is equal to 10 power minus 2 I cap meter square. The reason is as the plane is along yz plane, so area vector A bar is directed along x axis. How to calculate the flux, electric flux? Passing through that area. Phi suffix E is equal to, we have E bar dot A bar. E bar is 3 into 10 power 3 I cap dot area is 10 power minus 2 I cap. Both are in terms of SI system. its value is, we will get 30 Newton meter square per coulomb. So this is part A. While coming to part B, what is the flux through the same square if the normal to its plane makes a 60 degrees angle with x-axis? Here in this previous subpart, angle is 0, theta is 0, both are same in direction. But in this case, theta is given as 60 degrees. If we apply the same formula, electric flux, it is somewhat different value, phi suffix E dash I am writing, that is E bar dot A bar only, that is E A cos theta, that is equal to E value, just to take the magnitude 3 into 10 power 3, A 10 power minus 2 cos of 60 degrees. This is equal to, we will get 15 Newton meter square per coulomb. This is the answer for second part. Coming to 1.15. What is the net flux of the uniform electric field of exercise 1.14 through a cube of side 20 cm oriented so that its faces are parallel to the coordinate planes? This point is important. Its faces are parallel to the coordinate planes. It is parallel, at the same time the field is uniform. It is not uniform, it is uniform. So what will happen? The flux entering one face parallel to YZ plane is equal to the flux leaving other face parallel to YZ plane. So therefore, electric flux through other faces also zero. Hence, net flux through the cube is 0. This is the answer. So then net flux passing through the cube is 0 because the field is uniform. Whatever the flux is entering, the same amount of flux is leaving. So net flux will be 0. Thank you.